Hey guys, guess what? We're going to focus our gaze as we look at every singular thing under crystallization. Oh yes, crystallization is very fundamental, it's very cardinal and very, very, very important that you should know, because one sweet thing is that Jamb does not play with crystallization as well as your Waec exams. So crystallization cut across the two very, very well. And you see crystallization and then fractional crystallization. Let's rock them together as we move one after the other. Okay, the big question is, you're going to ask yourself, what is crystallization, right? Please, this definition must sink into you, because the definition alone is question. Very simple. Tell us this, that crystallization is a method of obtaining or forming. What are we obtaining? Solid crystals from a saturated solution without completely evaporating the solvent. There are three things you should type there. Number one, people say that crystallization is the method of obtaining or forming what? Solid crystals. In other words, we must obtain solid crystals. Number two, from a what? A saturated solution without completely evaporating the what? The solvents. If you watch, there are some group of words that do interplay here and all of that. Sometimes, maybe I don't know whether you find it difficult a bit, but let me break it down for you. There is what is called solvents, right? There is what is called solutes, and there is what is called your what? Your solution. Let me use water and then sugar or salts, any of them. What did we say water is? The definition of water, basically everywhere they say water is a universal word, solvent. In other words, water is a solvent. Ethanol is a solvent. Whatever dissolves in your whatever dissolves your solutes is called your solvent. That's why we say water is a what? Solvent, a universal solvent. At that, ethanol is a solvent. So just have the mental picture of it, that water is a solvent. But here you see your sugar. Sugar is a solute, because your solvent will dissolve your solutes. But it's not all solvent that can dissolve some solute. There are some solutes that will not dissolve in some solvents. So have that in mind. That's where there are some. If you take, for example, now your stone, your stone is stone solute or stone is solvent. Stone is solute. All those small stones, they are solutes. Will stone as a solute dissolve in water as a solvent? No. That means your stone is insoluble in water that is solvent. Sure, you are feeling it now. But your sugar or salt is soluble in your what? In your water, which is the solvent. And then mixture of your solvents and your solutes, if I add the two together, what am I going to have? I'm going to have solution at the end of the day. You having this in mind, what is crystallization? Crystallization is the method of obtaining or forming solid crystals from a saturated solution without completely evaporating the what? The solvent. Okay, let me take out something so that you follow me very, very fast. Yeah, let's go. Again, what is crystallization? The three things I told you to hold tight. It is the method of obtaining or forming what? Solid crystals, number one, from a saturated solution without completely evaporating the what? The solvent. Does evaporation take place in crystallization? Yes. Is it complete evaporation or partial evaporation? Partial evaporation without completely evaporating the what? The solvent. If you have this in mind, that means the only one that should be stressing you now is what is a saturated solution, because you'll be thinking it what is saturated solution. Now, let me tell you this. Solution can be saturated, solution can be unsaturated, solution can be super saturated. But that's not for this class anyway. Let's just learn what saturated solution is. Very simple. How do you define a saturated solution? What is the definition? Just tell us that a saturated solution contains the maximum amount of solutes. Think it yourself, like your sugar or your salt. The maximum amount of solutes that can dissolve in the solvent at a given temperature. A solution that contains the maximum amount of solute that can dissolve in a solvent at a given temperature. What is it called? Saturated solution. I told you we have a saturated solution, unsaturated solution, and supersaturated. In fact, in their order, of you arranging them: unsaturated solution, and then super saturated solution. But please, I'd like you to understand this, that in a saturated solution, no more solutes in a saturated can dissolve in the solvent unless conditions like temperature changes. In other words, can a saturated solution dissolve more solutes? No, it cannot dissolve any further more solutes. What is a saturated solution? A saturated solution is a solution that contains the maximum amount of solute, maximum to the peak amount of solute that can dissolve in the solvent at a given temperature. I know it's still looking confusing, but let me explain something to you. Imagine you are making your sugar water solution. Picture it with me. Your sugar is the what? Solute. Your water is the solvent. Solute plus solvent, what will it form? Solution. Your sugar water solution is a solution that contains sugar and water only. Right? So what happens there? If you're making sugar water solution, that means you have like a cup, right? And then you are adding, there is already water inside that cup. And then you are now adding your what? Your sugar to it. If you add, let me see, this is the cup here. Follow me very fast. This thing must enter you. This is the cup. And then there is water inside here, right? There is water here. And then you have to add 1 spoon of sugar. If you add that 1 spoon of sugar, the water will dissolve the entire sugar now, right? So the water still need more sugar. Because the water need more sugar, that solution is said to be unsaturated. But that unsaturated solution, what happened to it? You keep adding more sugar, adding more sugar to the water, adding more sugar to the water, and you are stirring it. At first, all of those sugar will do what? Dissolve. As all the sugar dissolve, you can still add more sugar. That solution is unsaturated. But you now get to a point, at a certain point, what happens? No more sugar will dissolve. Because no more sugar will dissolve, that solution is now what? Saturated. And since no more sugar will dissolve, what happens? It will start to settle. The more sugar you are adding, they will start to settle at the what? At the bottom. And because the sugar is settling at the bottom, a point comes when that solution is said to be what? Saturated. At first, you have your cup that you add your sugar to. That solution is what? Unsaturated. Because it can take more solute. A point now comes where it has gotten the maximum amount of solute it can take. If you keep adding more solute, what happens? Like the sugar, they will go and settle at the bottom. They will not dissolve. That solution is now said to be what? Saturated. Unless you now increase things like your temperature, you now increase temperature, right? So that the sugar can kind of like melt or something of that nature, so that it can dissolve in that solution. Then that's, you are now adding more and more solute to it. That solution will now become super saturated solution. That's why we said that a saturated, understand this with me, is simple. That's why we said that a saturated solution is a solution that contains the maximum amount of solutes that can dissolve in the solvent at a given what? Temperature. If you understand this very quickly with me, that means we can drive it back home to look at the definition of crystallization. Again, what is crystallization? Crystallization is a method of what? Obtaining or forming solid crystals from a what? A saturated solution without completely evaporating the solvent. Now listen to me. Before the end of this class, you get the whole of this. But please, in your crystallization, do we make use of unsaturated solution, saturated solution, or super saturated solution? What we make use of is what? A saturated what? Solution. And then we also carry out evaporation. But is it complete evaporation or partial evaporation? Partial evaporation. And then you obtain your what? Your solid crystals from it at the end of the day. If you get this very quickly with me, that means we are going to rock and look at the procedures for what? Crystallization. Now, in the procedure for crystallization, there are 3 powerful procedures that we apply there. Number 1 procedure is what is called heat the solution. Heat the solution. And which solution are we going to heat? The saturated solution. Now, what happens is this. Place the solution in a beaker. And which solution am I placing in that beaker? Saturated solution. And heat it using a what? A Bunsen burner. Right? And then the next thing is this. Evaporate parts of the solvent. That's why we said that in crystallization, evaporation take place, but you don't evaporate completely. Partial evaporation, you evaporate part of the solvent to create a saturated solution. Now, follow me very, very squarely and understand the whole of this. Give me the apparatus that we need here. Number one, you need your beaker. Number two, you need your Bunsen burner, and then any other thing that can now come up. But now, this is exactly how it occurs. First and foremost, to carry out crystallization, I need my beaker. Right? And this guy here is the beaker. I need my saturated solution inside that beaker. And the saturated solution that I need inside the beaker is exactly what I have here. Are you getting it now? This is the saturated solution. So this saturated solution, don't forget that it is your soluble solid in solution. Meaning that whatever it is, whatever that solute is what? Soluble. Inside the solution first, so that solute must be soluble. And then it is what is forming the saturated solution. So apart from the beaker and my saturated solution, what other thing do I need? Of course, I need my my tripod stand. You already know this. And then what will I use to heat it? There is where your Bunsen burner come in place. And since Bunsen burner have come in, what happens here? When I heat that, when I light up the Bunsen burner and I begin to heat that saturated solution, what happens? It begin to lose water, right? The solute, part of the solute begin to vaporize, and then they move out. And don't forget that whatever I have left inside here, we want to continue my experiment for you. And don't forget that as these guys continue to vaporize, of course, what is that process called? It's called evaporation. Is it complete evaporation or partial evaporation? It is called your partial evaporation, not complete evaporation. And don't forget that my saturated solution that is inside here, we want to continue the procedure too. I told you, you need your beaker, you need your saturated solution, you need your tripod stand, and your Bunsen burner. And what happens in step 2? Cool the solution. When I cool the solution, why am I doing that? Allow the hot saturated solution to cool. Whatever I have inside here, that is the hot saturated solution, allow it to cool. When it cools, crystals will form as it cools. So crystals will start to come out. That's why it is called crystallization. And then step 3, filter and dry. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons. You have access to your notes. You have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. How do I filter and dry? Very, very fast. Filter out the crystals and then dry them between filter paper. That means I need my filter paper. Now, how do I carry out this that involve your filter paper? Follow me. This guy, let me call it step A. All of these that I've done, this is your step A, right? I've explained the entire procedure that take place in step A for us. From step A, I'll now move to step B. And in that step B, you can carry out this practical yourself because it is the entire practical procedure I'm explaining for you directly. In that step B, and please, for your Jamb questions, you need a deep knowledge of these practical procedures in your mind to be able to answer all the questions. And in this step B, what do I need? I need exactly this. You have seen this probably in the laboratory before. This is what is called your clamp and stand. What is it called? Clamp and stand. Or you can call it your clamp stand. Aside the clamp and stand or the clamp stand, I also need my your filter funnel. Right? Aside the filter funnel, I need to insert my filter paper inside the filter funnel. And after inserting the filter paper inside the filter funnel, you see this your hot saturated solution. Carry it and pour it inside the filter paper. This is your filter paper, right? That hot saturated solution, pour it inside that filter paper. And this is your hot saturated solution that you have there. Follow me squarely so that you know the procedure, how everything is done. And of course, you need your beaker. Carry a beaker and put it on the filter funnel. This guy is your beaker. And since I've put the beaker there, what happens here? Since the hot saturated solution is inside that filter paper, what happens? It will begin to drop water, right? Water will begin to drop, and that's your what? Your filtrate. All of these guys begin to drop, and this is what forms the what? The filtrate. After I've obtained my filtrate, you know, whatever is left inside this your filter paper, what do you call it? That's called your what? Your residue. What is it called? Residue. That residue is what I now need in my step 3. Then I'll carry something like your tray, right? You carry something like your tray, and then you pour the residue inside it and you spread it. And then what happens, my guy? What happens is that you're going to see crystals of soluble solids. All of them will begin to precipitate out. This process is what we call your what? Your crystallization. Does it make sense? The entire crystallization process is what? Very, very simple, easy and direct. Just follow the setup. A, follow them, your B, and then your what? Your C. You have obtained your what? Your crystallization, easy and direct, and you are out of there. If you get this very quickly with me, that means we are good to thrive and ride on. If you get this very quickly, again, what is your what? Crystallization. Crystallization, I told you, is the method of what? Obtaining or forming what? Your solid crystals from a saturated solution without completely evaporating the what? The solvent. Very simple, easy, and what? Direct. Guess what? Now that you understand this, we are going to look at the advantages of crystallization. Very important. What are the advantages of crystallization one after the other? I'll tell you a couple of them. Number one, it is ideal for recovering solids that decompose or melt easily when directly heated. That's why your sugar solution, if you heat sugar too much, it will decompose on heating. Unlike salt, salt does not decompose on heating. Like your sodium chloride does not decompose on heating. Not all salt, sodium chloride does not decompose on heating. But sure, you see your sugar decomposes on heating. So one advantage of crystallization is that you use it for your salts or your solids that decompose or melt easily when you heat them directly. And don't forget this, that your purer crystals, pure, are produced as impurities remain in the what? In the solution. Another advantage of crystallization, number 2, that we have said, does it produce purer crystals or impure crystals? Purer crystals are obtained at the what? End of the day. And again, don't forget the number 1, very important. Crystallization is only used for solids that decompose or melt easily when you heat them what? Directly. If you get that, please, what are the examples of your what? Your crystallization? What do you carry out? Where do you carry out crystallization majorly? Jamb And Waec question, they will not fail to ask you. When it comes to crystallization, don't forget this, that crystallization is used for crystallizing sugar from sugar solution. When you just read the exam question, sugar solution, where is the answer? Crystallization is the answer, no stress. And of course, crystallization and evaporation to dryness, what are their differences? There are 3 powerful differences between crystallization and evaporation to dryness. How many? 3 of them. Yes. Number 1 difference is in terms of speed. In terms of what? Speed. When it comes to crystallization, don't forget that crystallization is slower than evaporation to dryness, because in evaporation to dryness, you just heat it directly, and thereafter all the water will go out, and then you obtain your what? Your crystals at the end of the day, your crystals of whatever sort you are obtaining at the end of the day. But in your crystallization, it is slower, because there you need your clamp and stand. You need your what? Your filter funnel. Before you can carry out all of this procedure, you will heat it gently, and all of the stress and the procedure is long in crystallization. Number 2 difference between your crystallization and evaporation to dryness is in terms of recovery. Yes, very important. In your crystallization, please, not all crystals can be recovered through what? Crystallization. You cannot recover all crystals. But in your evaporation to dryness, you will recover all your crystals, because all it involves is just heat it directly and then you get your crystals. But in crystallization, not all crystals can be recovered by your what? Crystallization. In terms of speed, which one is faster? Evaporation to dryness is faster. Which one is slower? Crystallization is what? Slower. And then number 3 difference is in terms of purity. Yes. Which one wins in terms of purity? Is it crystallization or evaporation to dryness? Of course, crystallization wins, because crystallization yields purer products, since impurities may stay in the solution. Which one yields purer products? Crystallization. Now, which one is it that you will recover all the crystals evaporation to dryness? In terms of speed, which one is faster, evaporation to dryness? Which one is lower, crystallization? Which one that all the crystals you're not going to recover them, crystallization? Which one give you purity? Crystallization give you the highest level of what purity that you think of. If you get this quickly with me, no time to waste time or no time to check time at all. Guess what? We're going to look at again the definition of crystallization. You see, I've given you this definition back to back so that you just stick inside you. What is crystallization? The method of obtaining or forming solid crystals from a saturated solution without completely evaporating the what? Solvent. What is it called? Crystallization. Right? Yeah, let's go there. There's what is called recrystallization. So crystallization is different from recrystallization. What is the difference? Recrystallization is the process of repeating. From the name now, you are repeating the crystallization process, but this time you are using fresh solvents. What are you using this time? Fresh solvents. What is the advantage of recrystallization? It obtains purer crystals than crystallization itself. Crystallization and evaporation to dryness, which can give you purer crystals. Crystallization gives purer crystals and evaporation to dryness. Recrystallization and crystallization, which one will even give higher level of purity. Recrystallization gives higher level of what? Purity, because in recrystallization, we are using what? Fresh solvent in recrystallization. Now we are repeating crystallization procedure. And you getting it now? So that's just it. What is recrystallization? It is the process of repeating the crystallization process using fresh solvent to obtain much more purer what? Crystals. You get this very quickly with me. No time. Let's rock the Jamb past questions. Look at the Jamb past questions. Jamb 2005, question 25. Jamb has this beautiful question that says, sugar is separated from its impurities by how do you separate? I told you anytime you don't hear sugar. Because sugar will decompose on eating. How do you separate it from its impurities? Is it by distillation? Is it by evaporation? Is it by precipitation? Or it is by crystallization? What is the answer? Crystallization. Option D is the answer. You only choose another thing on the ground that crystallization is not there. If crystallization is not there, that's why you now go and think of evaporation. But once you see crystallization, try me. Go and choose another thing. What is the answer? Option D, crystallization. Why is the option D? It is option D because we have established this, that crystallization is the method. You never see anything. This definition must enter you. Crystallization is the method of obtaining or forming what? Solid crystals from a saturated solution without completely evaporating the what? The solvent. And also, don't forget the examples of the major example of your crystallization that I gave you. The example is what? Crystallizing sugar from your what? Your sugar what? Solution. If you get this very quickly with me, guess what? Your WAEC past questions. What is it that WAEC has asked under crystallization? WAEC 2005 question 34. They get this interesting question. A solid can be obtained from its saturated solution by how do you obtain solid from the saturated? You just hear saturated solution and you are obtaining solid. You don't think it twice now. Is it filtration, or it is crystallization, or it is condensation, or it is decomposition? What is the answer? Crystallization. Option B is the answer. Why? Told you again and again and again that when you come to your crystallization, please, I gave you the advantages of crystallization. I gave you two. Number one, it is ideal for recovering solids, right, that decompose or melt easily when directly what? Heated, right? And another thing is this: they produce purer what? Crystals. Purer crystals are produced as impurities will remain in the solution. Don't forget this. I've given you all of this. And look at another question, WAEC 2020, question 11. Look at the sweet question they asked. The most suitable process of obtaining water from an aqueous solution of sugar. What is the most suitable method of obtaining water from an aqueous solution of sugar? What is it? Is it, don't forget it, you are obtaining water from an aqueous solution of your what? Sugar. What is the method? Is it crystallization? Is it distillation? Is it filtration? Or it is your what? Decantation? What is the answer? Crystallization. Option A is the correct answer. You get that very quickly with me. Now look at WAEC 2021 question 36. There's this interesting and sweet question. Potassium triazonitrate 5. Potassium triazonitrate 5, right? That's your KNO3. Potassium triazonitrate 5 can be obtained from its solution by Potassium triazonitrate 5, this guy here is a salt, right? It can be obtained from its solution by, very simple, distillation, evaporation, crystallization, and then filtration. Potassium triazonitrate 5 will decompose on heating. And because it will decompose on heating, and it's a salt, what will you use to obtain it now? That's crystallization option. What? C is the correct answer, and then you are out of there. And don't forget this very quickly with me. Don't forget, always remember that potassium triazonitrate 5, KMnO4, is popularly called potassium nitrate. It is obtained from its aqueous solution through the process of what? Crystallization. Why? Because it will decompose on what? Heating. Get that very fast with me. Guess what? That is everything about crystallization. In the next class, we are going to look at your fractional crystallization together. And I'll see you in that class. Enjoy. Bye-bye. Catch you there. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.